This is the 12.3 mini lesson on inscribed shapes. So recall that the area formula for a triangle is area equals 1/2 base times height, where b is the length of the base of the triangle, h is the height. An inscribed circle is a circle that fits exactly within the boundaries of another shape. It is the largest possible circle that will fit inside a plane figure. So inscribed circle D intersects the equilateral triangle at the midpoint of each side. So this would be the middle of this side. This is the middle of this side. Here's the middle of this side. The radius is R, and then each side is S. So they want us to draw 3 line segments from the center point of the circle to each corner of the triangle to form 3 congruent triangles. So I'm going from here to here, here to here, here to here. So I formed 1, 2, 3 triangles. How is the radius of the circle R related to the triangles? The radius, you're going to notice, that is the radius is the height of the triangle. So we want to write a formula to describe the area of each of the 3 triangles we drew. Okay, so area of a triangle equals 1/2 the base, which is S, the height, which is R. Now we want to write a formula to describe the area of the large triangle. Well, that's the small one 3 times. So if I take this and multiply it by 3, area equals 3 times 1/2 S R. And now I know I can make this look like a fraction. I can't simplify, but I can multiply these 2 fractions and get 3/2 SR. So 4, we want to write a formula to describe the perimeter of the large triangle. The perimeter is S plus S plus S. It's the distance around. Perimeter is S plus S plus S, or that's 3S. Now we want to write a formula to describe the area of the triangle in terms of the perimeter. So what I'm going to do is right here, I'm going to solve this and isolate for S. So if I divide both sides by 3, I get a side is equal to the perimeter divided by 3. I'm going to take this and substitute it into the area formula. So I'm going to rewrite area equals 3/2 SR. S is P over 3. So I'm going to take this and put it in place of S. So area equals 3/2. Take out the S and write P over 3R. Now I can simplify. These 3's cancel. So I get area equals P over R divided by 2. Or another way of saying that is area equals 1/2 times the perimeter times the radius. So a lot of algebra that we're doing to put these equations all together. So let's try this now with a circle inscribed in a square. So again, they want me to draw line segments connecting the corners and the center of the circle. So by doing so, you can see I made 4 congruent triangles. So how is the radius related to the 4 triangles? Again, the radius is the height of the triangle. So now we're going to write a formula to describe the area of each of the 4. So I want an area of this. Area equals 1/2 base times height. Area equals 1/2. The base is S. The height is R. Okay, write a formula to describe the area of the quadrilateral. So I need this area, this, and this. So this area 4 times. So I'm going to take that area and I'm going to multiply it by 4. So again, when I'm doing this, multiplying fractions, I can simplify. 2 goes in 2 once, 2 goes in 4 twice, and I get area equals 2SR. Now I want to write a formula for the perimeter. So the perimeter would be S plus S plus S plus S. Perimeter equals S plus S plus S plus S, or perimeter equals 4S. And I'm going to right away isolate for S. Divide both sides by 4. So S is equal to the perimeter over 4. Okay, now I'm going to go back to my area. Area equals 2SR. And I'm going to take S being P over 4. I'm going to put it in place of that. So area equals 2 times P over 4 times R. Well, I can simplify this. 2 goes in 2 once and in 4 twice. So area equals perimeter times the radius over 2, or I could write it area equals 1/2 perimeter times radius. So if we look, those two formulas are the same. So when we have inscribed circles, we can get this formula. So we could keep going with the next few pages and trying it with a few more shapes. I'm going to now move all the way to page 613, the talk, and see if we can now make a connection between this and a formula for area of a circle. So we've established that the area of a regular polygon is 1/2 the perimeter times the radius. So you have observed that as the number of sides of that polygon increases, it looks more like a circle. So this formula should be able to apply to circles. And we know that technically the perimeter of a circle is called a circumference. So they're taking this formula, and instead of P, we just replaced a C. So now I'm looking at this formula. And we already know that the circumference is 2 pi r. We figured that out in a different lesson. So now we're going to substitute an equivalent expression for C into the area formula. So I'm taking my area formula, I'm going to take C out, and I'm going to replace it with this. So I'm going to rewrite it. Area equals 1/2 times, take out C and write 2 pi r. But then I still have this r, so now I have 2 of them. I can simplify this. The 2's both cancel. So that gives me 1. So I have pi r r. Area equals pi r squared. That's how we get the formula for area of a circle.